This we started looking at it the other day, and the phospholipid is made of this glycerol molecule. Glycerol is a 3-carbon alcohol. Anytime you hear, let's go back in some of the word usage, vocabulary usage. So when we look at words like os, endings like with os, then you know it's a sugar. If you have an ending like ol, ol, then you know it's an alcohol. Do what? Yeah, look in that cabinet. There should be some somewhere, unless the kids all took them and didn't return them. I got markers, pencils, that kind of stuff. So sugar, alcohol, all right. And if you have this 3-letter ending called ASE, then you know it's an enzyme, and we'll talk about enzymes next week. So you have those 3 things. Are we clear? Those are endings. Those are suffixes. It'll help you a lot if you know these suffixes. Yeah, I'm sorry, I don't have time to look for them. So know those suffixes. This is a 3-carbon sugar called glycerol. Alcohol called glycerol, and it looks in its native form. It looks like this, and then you have an OH group sticking out here, and alcohols have a lot of OH groups. Oops, not carbon. That's all. It's a real simple molecule, but it's very, very important because it's used to make a lot of different things in your body and in life and living things in general. And when you take it and you add it to a lipid, remember, what is a lipid? A lipid is a fatty acid. You remember I was talking about fatty acids, correct? All right, fatty acids. This is like the 3rd time now I'm going over it. So fatty acids has a C double bond O, OH. That's the acid part. This is the acid part, specifically a carboxylic acid. Right? That's the group, the functional group. We said early on we should know what this is. All right, this is a carboxylic acid group, okay? You know what, let me use a different color. Carboxylic acid group. And then you have this long chain of carbons. It's basically a bunch of carbons and hydrogens, also known as a hydrocarbon. Why hydrocarbon? Because it's just hydrogen and carbon. That is a fatty acid. There's a bunch of them. Then at the end, you have 4 hydrogens at the end to cap it off. But that's a carb. This is a fatty acid, right? This is the fat part down here. This is a fat. Any kind of fat is going to have a bunch of carbons and hydrogens. Mostly carbon and hydrogens. Not a lot of oxygen. Not a lot of other elements, just carbon and hydrogen. Those are things you have to know. So in order to put these together, what could happen is you can take this carboxylic acid group. Over here, I'm just going to draw, you know what, let me just. You can just take this over here, and what will happen is you're going to get dehydration synthesis. You're going to get an oxygen and an OH group are going to come together to form what? OH and H are going to come together to form what? What are those two going to form? OH plus H equals what? Water. H2O. H2O. So that's why we call it dehydration synthesis. Dehydration synthesis. Obviously, D is not a suffix, it's a what? Prefix. And D means, not, right? Or undo, or whatever you want to call it. Hydration is a root word, and that's just water, right? We all agree on that? We've heard of hydration. We have to be hydrated. We know that means water. So synthesis means to what? What does synthesis mean? Anybody? To make. Hydration, water. Put it all together and you're taking water out. How do I know you're taking water out? This means water. Hydration means water. What does D mean? Not. Right? So not hydrated, meaning what? Taking water out. Is that clear? Yes. So dehydration, opposite of adding water. When you hydrate, what do? You drink water. If you're dehydrating, what are you doing? Releasing water, losing water. Does that make sense? One is water going in, the other one's water going out. So this is dehydration. Synthesis just means making. Well, this is what we do in our bodies all the time. We make molecules by removing water. So when we take and we add these two together, OH and H combine to make water, and then that leaves oxygen needing a bond, that leaves carbon needing a bond. Remember, carbon needs two bonds, correct? And carbon needs 4 bonds, and oxygen needs 2 bonds, correct?
You said that we make molecules by removing water?
Yeah, by removing water. That's really, let's go ahead together, let's put that in our Cornell notes. We would put it over here on the side. And we'd say, in general, we make molecules by removing OH and H in the form of water. Is that making a little sense? All right. Are we good? Anybody have any questions? I know it can be a little confusing if you're not careful how you draw things, and let me know if I can go on. Can I go on? You have to understand that. Dehydration synthesis means you're making something. In this case, we're making a fatty acid, a triglyceride, or ultimately we'll make a phospholipid. But these two come out, what are you going to be left with? What do you think you're going to be left with? So water comes out. Can I erase this now? I'm going to erase it because water's leaving. I'm just going to erase the water. It's gone. So this OH and this H is gone, correct? This H here is gone. There's an oxygen left. It needs... This OH is gone. So now we're left with this carbon with something's missing, and oxygen, there's something missing. What do you think is going to happen? What do you think is going to happen? Look at it. They need a bond. What's going to happen? What do you think's going to happen? This is one group here, the fatty acid, or what used to be a fatty acid. Here's this oxygen, part of this glycerol. It's sitting here. What do you think's going to happen between these two? This one needs a bond. This one needs a bond. They're going to connect. Just like our models, right? Just like the two little magnets snapping together. They're going to connect. Good. So what you're going to get is, oops, let me erase the other thing too, because I don't want you to get confused. So there's oxygen, needs 2 bonds. It only has 1. Carbon needs 4 bonds. It has 1, 2, 3. Well, heck, they can come together and bond like that. And that could happen. How many times do you think this is going to happen here? Multiple times is correct. So that's 1 here. It'll happen again here. It can happen a 3rd time. If it happens a 3rd time, we call it a triglyceride. By the way, there would be a water for each one, okay? If it happened a 3rd time, we would get a triglyceride. And that's something doctors test for all the time in your blood tests. All right? They test for triglycerides. Are we all good with this? Yes? So you have this thing called glycerol, and then you could add fatty acids. You can add 3 of them, and we call it a triglyceride, 3 fatty acids on it. Now, if we added a phosphate group, now, interesting thing about phosphates, let's take a look at it again, just to remind you. Remember, we've been dealing with phosphates for a while now, haven't we? Oopsie. Come on. So we've been dealing with phosphate for a while, correct? This is phosphate. Here's phosphorus, double bonded oxygen. I said, when we did DNA, we're just going to put a P with a circle around it, right? See, there's a circle around it. There it is. But we're going to look at, see, it's actually PO4. It has a negative charge. Do you see there's a negative charge there? Because that's very important that you understand that that is a negative charge. That is not a partial charge. It's a full negative charge. And then here you have that idea of an R group again. So you can add stuff to this R group. You can add all kinds of different things to that R group. And that's going to become important later. Okay? Yes or no? We're good? Okay. So this is called a phospholipid. This fatty acid, do you remember us talking about saturated and unsaturated? Do I have to go over it again? So let me go over it again, just to be clear. Whenever you have a chain of carbons, they have hydrogens all on them. They all have single bonds. They all have single bonds. We call these saturated. Only single bonds. Okay? And if there's a double bond, then we call it what? What do we call it if it's a double bond? Unsaturated, correct. So when you hear saturated fatty acids and you hear about in commercials, you read it on the labels. What they're talking about is, do they have double bonds or not? And why is that important to remind you it's important because it turns out that the double bond is shorter. This double bond is shorter. So because it's shorter, the long chain of carbons bends. So at room temperature, at the same temperature, this saturated one, will be solid at room temperature. And this unsaturated one, well, what do you think? What do you think the unsaturated is going to be?
Liquid?
That's right. Someone want to close that door, so. It's a double bond, bless you. And because it's short, this is liquid at room temperature. So what are examples of solid fats that are solid at room temperature? I gave you examples like butter, right? Right? Butter is a fat that's solid at room temperature. I gave you an example like the white part of a raw steak. Didn't I say that? If you have a raw steak, before you cook it, you see the white streaks in it. I showed you a picture of it because some of you didn't recognize what I was talking about. And do you remember that conversation? Well, it happened. I promise you. If you don't remember it, you may not have been in the room, but we did have that conversation. So the white part, the white streaks, you call it marbling in meat. It's just fat, but it's saturated fat. Liquid at room temperature, the examples are what we gave were olive oil, right, and corn oil. Now, at regular room temperature, it's liquid, but you don't want to pour these down the drain because when it gets cold in those drains, these can also become solid. Right? We're all good with this so far? Are we good? All right. So when we put them together, we can get this thing called a phospholipid. We take this phosphate, this P, with a bunch of O's on it. And actually, they generally have OHs. And then this O here can have a negative. So this phosphate is charged, negative charge. Right? Let me highlight the negative. It's a negative charge. That's going to become important. These here, these fats, the fat part of this and the glycerol part, no charge. And nonpolar. They're all sharing equally. Do we remember our discussion about water and polarity or not? I'm going to say not. So we have oxygen and 2 hydrogens. This is water. Now water's problem it's not really a problem, but it's a result, is that oxygen is more electronegative, it's stronger. Do you remember me giving you the example of me not sharing evenly with my brothers and sisters? Then when we got pizza, I would always get an extra slice, or else. Mm-hmm. That's right, I gave you that example, that I was a bully to my brothers and sisters. Oxygen here is a bully to the hydrogens. That's why I gave you that example.
Are there is oxygen like a bigger bond than hydrogen?
Very good. It's stronger. It pulls stronger. It's bigger and stronger, so it pulls the electrons more. So hydrogen becomes a little bit more positive. Oxygen becomes a little bit more negative. That is different from this negative charge. This is a negative charge. Do you see that? Mm-hmm. That is different from what's happening here. That is not what is happening here. But you do have a partially positive charge. So how do we make a symbol? How do I put a positive and you not get confused that this is about this not being a charge but a partial charge? We put an extra symbol on it. We put a weird looking S, and that's the symbol delta. Yeah, we did talk about that. I know we did. Yeah, we have. We talked about this before. But I know there's a lot of stuff's gone on since then, so that's all right. So there's delta positive, all right? Delta just means that it's a partial charge. It's not a full charge. That's all we mean. So it's a weak, like a weak magnet versus a strong magnet. You know the difference, right? You put a strong magnet on a refrigerator and it sticks. Put a weak magnet on a refrigerator, what happens? It doesn't stick. It just slides down and falls off, right? So, but it does stick, kinda. But then it just kind of slips down and falls off, right? You've had that experience, correct? So that is a weak magnet. So this is what we're dealing with here. These are kind of weak little attractions. This is stronger attraction. But they both do have that kind of electronegative charge. So this oxygen, if this side, right, of this molecule, it's a molecule, correct? Correct? Yeah, it's a molecule. If this side of the molecule is positive, partially positive, what do you think the other side is? Negative, correct? Partially negative. How do we designate partial negativity? We have to do what? Draw a delta and then the negative. So this was a delta with a positive. This is a delta with a positive. That's a delta with a negative. So because there's two sides now, just like the North Pole and the South Pole, because there's two sides, side 1 and side 2, side positive and side negative, and it's a partial negative and a partial positive, right? So side 1 and side 2, we call these molecules that do this polar. Polar. Like the North Pole and the South Pole. There's a really big rule in science, really big. It runs all, and you'll use it in chemistry, in cosmetology, in biology, in chemistry. It's a serious rule. You know it. But let me give you an example to see if you can. Have you ever been around when you walk down the street after a rainstorm? Have you seen a puddle? Right, right on the edge of the street. There's a little puddle of water. Have you?
Like on the street.
Yeah, anywhere. And you're sitting, you're walking down the whatever, and there's a puddle, there's some water there. Have you seen that?
Yeah, I think we all seen that.
Okay, I don't know. I'm asking. And what happens is, have you ever seen oil sitting on the water?
Yeah.
like some car came by and there's just some oil floating. Does it mix?
No.
Oil and water doesn't mix, does it?
No.
So these fats, and the same thing goes with olive oil, corn oil, any fat. It'll sit by itself. Yeah, so in any case, what we call this, and so what we say, it's not dissolving. So that oil is not dissolved by water, right? But if we take and we add sugar or salt to water, what happens to it? It mixes really well. It dissolves, right? And it disappears. We don't see it anymore. If we put oil in water, we see it. So when this happens, so this rule happens all over the place. It's happening in your body right now. So what we call this is, or what we say is, this is really difficult. A lot of hard spelling here. Are you ready? Like dissolves like. Wow, that was hard. Like dissolves like. Like dissolves like.
Explain that, because I'm really not understanding.
Okay, I'm about to explain it, but just write that down. Like dissolves like. Can someone else make a guess? I haven't explained it. It's a good suggestion that I explain it.
Talking about like sugar and like salt.
Yeah. Sugar, salt, and water mix. Oil and water don't mix. Like dissolves. So what does that suggest? So sugar, salt, and water must be similar if this is a rule, right? And oil must be different, correct? And what do we know about water? What is water? What's water? It's polar.
Oh, I was about to say water.
Water's polar, so it's slightly charged. So what it turns out to be is that polar solvents, way back in August, we talked about solvents, solute and solutions. Yeah, polar solvents, I know, it's a long time ago. Polar solvents, that stuff that does the dissolving, like water, right? Whatever you're putting the solute into. So let me make a little graphic up here. This is the solvent. That's what's dissolving something. ing, right? Something. This is what's doing the dissolve. Then you have the solute, which is what is being dissolved. That gets put in. Are we clear? Yes or no?
Yeah.
All right. So polar solvents dissolve polar solvents, as polar solutes, polar and ionic solutes. So if water dissolves it, if it dissolves it easily, it's probably polar or ionic. What do I mean by ionic? Something with a full charge. A molecule or an atom with a full charge. A full negative or a full positive. What do I mean by polar? Something with a partial positive or partial negative. Are we good with this? All right. Where nonpolar materials dissolve nonpolar materials. I'm going to give you 3 examples real quick, and they're I think most of you know this already. This is stuff you know, you just haven't thought about it. So let me give you 3 examples real quick. So, nail polish. Who uses nail polish in the room or seen someone use nail? Who's seen someone use nail polish, whether themselves or someone else? Okay, so everyone. So you see these people walking around with color on their nails. Do you see them get wet? Do they get water on them, on those nails? Have you ever washed your hands or whatever? Yeah, right? Why doesn't the nail polish come off? It's hydrophobic because it doesn't get dissolved by water. Water won't dissolve it. It's very hydrophobic. Put it down, yeah. So it's hydrophobic. Does that make sense?
Yeah.
Now, what if you want to get these people that you saw with nail polish? They change the color. If they can't wash it off, how do they get it off? Acetone. What is acetone then? What is acetone?
Oh, acetone is nail remover.
Yeah, but what's nail polish remover? What is it?
Well, basically, like,
Which is nonpolar. So it's a nonpolar solvent. So you can use a nonpolar solvent to remove nonpolar materials, permanent markers, quote unquote permanent markers. Why do you use these to write on your binder? Why not just use a regular marker?
I mean, it's like color.
A regular marker is polar, and what happens when it rains or gets wet? It runs, right? That's no good. Nobody wants that. This won't run with a nonpolar and with polar molecule. So this is nonpolar and a regular marker is polar. Okay, water. How do you get this stuff off? Acetone or alcohol will remove. This is not permanent. It just doesn't dissolve with water. It dissolves with a non-polar solvent like alcohol or acetone. Does that make sense? So people are like, it's permanent. No, it's not. It's just I just get some, paint remover. What's paint remover? A non-polar solvent. Are we clear? Like dissolves like. There's going to be a lab on Monday, and you're going to have to use this rule. Like dissolves like. It's a fun lab. Tuesday. Whatever, bro. Just chill on this. Details. The details. I'm trying to stay focused here. So you're going to have a lab on Monday. Today, for the rest of this period, I'd like you to do the following. Pay attention because we don't have a lot of time. And if you got to do it for homework, do it for homework. Here, pay attention. You're going to take this paper and you're going to fold it this way. Then you're going to make one of these for each of these different ideas. All right? So one idea that we went through here, start at the beginning. Maybe you do suffixes and enzyme, sugar, alcohol, fatty acid, carboxylic acid. So let's look at first at doing vocabulary. So for each one of these, take a pair of scissors. You could just rip them if you like. Take a pair of scissors though and cut this way. You see me doing this? I'm going to do one too.
How many?
However many words you have, you're going to make one for each of the words. What words? Os, suffix os, suffix ace, suffix ol. Correct? Do you see that on the board?
Yeah.
All right. And you have what else? Fatty acids, carboxylic acid, correct?
Yeah.
I'm going to do one. You guys are going to do one. So you have this. On this one sheet, I got 1, 2, 3, 4, 5, 6, 7. 7 words I can put on one sheet. And which ones am I going to choose to do on mine? You choose yours, but I'm telling you which ones are important. These three, I'm going to put on one of the little flaps, all three of them, because they're just suffixes. On this one, I'm going to put on its own. And I'm going to, you know what I'm going to do? I'm going to do something crazy. I'm not only going to put the definition that it's just a bunch of carbons and hydrogens, I'm also going to, and that has a carboxylic acid, right? That's the words that have a fat and a bunch of carbons and hydrogens and a carboxylic acid. I'm also going to put the word fatty acid. There's glycerol. I'm going to put that's an alcohol, but I'm also going to draw it. So I'm going to draw these on the inside. So I'm going to put the word here, fatty acid. Is that clear? And in here, I'm going to draw it and write the definition. So when I'm going to go study my vocabulary, all I do is fatty acid. I think it's this. I can just flip it. Does that make sense? And the next one, you can flip it. All right, why do you look confused? What are you confused about? Say it. Anybody? What's confusing about what I'm saying?
I'm not confused. It's just like I don't know how to look at
You don't know what? No, you do it for homework if you run out of time. I'm giving you the paper and the scissors to cut the paper now. This is studying. Oh, I studied last night, Mr. Mendoza. This is what studying is. Yeah, for reals. This is making index cards. This is how you don't fail a test. Are we clear? So let's go. You got 4 minutes. You can cut up your paper. You punch a hole in the corner here. Punch a hole in the corner. I expect to see at least 3 of these by Monday, because tomorrow you're going to have an activity that's going to cover polar and nonpolar. There'll be some more vocabularies. So I would take 3 of these with you.
3?
I would take 3. And you can punch a hole in it so you keep it in your binder.
Those are commercial stuff. I don't know what.
Yeah, probably for a field trip.
Yeah.
There's a hole punch around here somewhere. All right, we're all good? Do we all understand? I recorded this. I'll post it. It's 37 minutes long, so it's not that long. You can fast forward and rewind whatever you need. I explained everything. I modeled it. You see, I highlighted the vocabulary words. I would do phospholipid. I would do phosphate. I would do lipid. I would do fatty acid. I would do polar, nonpolar. I would do like dissolves like. I would do saturated, unsaturated. I would do water as an example. I would do polar versus nonpolar. I would do solute, solvent, solution. So I expect one of these flaps, doing a vocabulary word for every one of those ideas by Monday.
You want 7 on each?
Or however many you want. It's your flap. Does that make sense? Yeah. Like if you put nonpolar, polar on one, I put polar versus nonpolar, my flap could be a little bigger, and I could just have polar versus nonpolar and just open it up. But it's your design. Wait, you don't understand what? So you fold it? Yeah? You cut it? How wide do you cut it? Well, it depends on what you're going to write here. All right. So if you're writing a lot, then you want the flap to be bigger. If you have a big drawing, like maybe you want to draw this whole. Your idea is you want to draw the whole phospholipid here, right, with all the labels. So your flap might be this big. Does that make sense? So instead of making these 7 flaps. Where are my scissors? Somebody take it. So instead of 7 flaps, I might have 4 flaps in one. Does that make sense? So, my darling, watch. So let me demonstrate for you, okay? So on this front, I'll give you this. So you scared me. I'm old. I'll die. Don't do that. On this side, you put phospholipid.
Time to go, guys.
So that's the word. And I'm like, "Hey, what is a phospholipid again? I forgot. What do you do? Flip it, open, and there it is. And what's going to be there? It's going to be the example, exactly. And you can draw this one, you can draw any one of them, but I'm going to go ahead and draw this one. You can draw P, C, C, C. You draw here O, P, O, negative. This is H, this is H, this is H2, this is C, this is O, C.
I'm sorry, I get it.
Right, a bunch of C's. And this is, let me finish it because I started it. I don't like leaving things half done. Oh, there's a double bond O here, obviously, because this is. I'm gonna put dot, okay? And so that's a phospholipid, and I would even go as far as draw this and kind of draw it. But then I would also draw it, put an arrow, right? That would do, because you're gonna see it more like this than you are any other way. This is the head, and these are the two tails. Head and two tails. That's what you're seeing here, right? And then this side up here, we're gonna call it. See how you have this whole back of the card too? You don't have to. You're not limited to just this side. Yeah. On this side, you could put hydro.
No, y'all chat is crazy. Y'all chat is crazy. Who's chat?
Philic.
When y'all little group chat, y'all feelings going off and stuff like
right?
What?
Because it's charged. Right? And then down here, these are what? Hydrophobic tails. So there it is, hydrophobic tails, hydrophilic heads. I have two drawings, and I know that's a what? Phospholipid. So now when I go to study, the word study, I go, phospholipid is this. Phospholipid is this. And you'll do the same thing for hydrophobic and hydrophilic and all the other vocabulary words. All the vocabulary words that you think you don't already know. Does that make sense? Oh, you got it. All right, so here's that one. Did you need help? All right.